Knowledge graphs are all the hype now, but ontologies, taxonomies, and knowledge graphs are new inventions. Most of them have been studied for decades, and Google popularized the knowledge graph in 2012 by building on decades of semantic web research. And despite the current buzz, these concepts build on established work. And when we look at all of them, we can think of metadata as a foundation. It tells you what data means, where it came from, and how it connects. But why is it all the hype now? AI needs context. LLMs are powerful but blind. They need clear definitions, trusted sources, and connected concepts. And metadata provides these backbones. And knowledge graphs, taxonomies, and ontologies use the metadata to make it more usable by the LLM. So your first steps are typically you start with the facts, something like your table names, column types, data flows, access patterns. Then you add meaning. So you add business terms, common definitions, key relationships, usage rules, and then you connect everything. You link the technical to the business terms. You map data flow to processes. You tie the metrics to the sources, and you build from the ground up. So metadata is new, but it's really important for AI systems, data governance, business intelligence, and also cross-team collaboration in larger enterprises. And today we are talking to Juan Sequeda, who has been building data catalogs, ontologies, and knowledge graphs for decades. And we will be talking about how they are building knowledge graphs and how you could apply it to your own use cases. Let's do it. What do you think is the difference between like all the different buzzwords that are being thrown around? A data catalog, knowledge graphs, ontologies, taxonomies, and how do they work together?
Okay, they're buzzwords now because people have been because it's becoming popular, but it is not a buzzword. The word ontology, all those things you said, ontologies, taxonomies, those are things that have been worked on, defined for decades and decades. If not, you can go back to the history of this for since the Greeks, right? So just organizing knowledge is not a new thing, right? So that's the one thing I would put out there. So this is not a new buzz thing people are trying to go do. Knowledge graphs, again, I remind people the word knowledge graph became popularized when Google made a blog post in 2012 and where they introduced their concept of a knowledge graph, which is based on all the work that at that time that came out of the semantic web research community. So when people say, "Oh," so then we can talk about the semantic web and stuff. But so you have all these people working on things, and the semantic web community was building on so many other technologies and approaches from the past, right? You always build on the shoulders of giants. So then knowledge graphs was popularized by Google around this, and now with AI and LLMs, I'd argue that the work that our lab did over 2 years ago now, we were the first ones, to the best of my knowledge, to say, "Hey, we believe if LLMs are going to be used to chat with your data, specifically chat with your structured data, you need semantics, you need ontologies, you need a knowledge graph." So the research that we put out was showing, hey, if you put a knowledge graph layer on top of your relational databases and you do question answering over your knowledge graph instead of just directly over your SQL, the accuracy increased like 3x was our original research. And that spawned, and people had already been talking about knowledge graphs and LLMs. Yeah, those should go together. But we were, to the best of my knowledge, we're the first ones to actually put some numbers on it, saying how well does it actually improve, and is it actually worth that improvement? And then you can start seeing things about graph rag and all these coming up. But so that's my long story there. But the quick thing is, it's not. We're hearing it more, but it's not a buzzword that people have just made it up recently for this stuff.
And is it because it seems a lot, you're connecting to a lot of different data sources, you're cataloging what does everything mean, what are the different definitions of the different data types, what are ontologies, taxonomies that we are using across the data. Is there a certain scale you first have to reach in your maturity and in your AI and data journey before it really becomes relevant? Or should you start with it from the get-go, thinking about what are the connections between the different data sources and how should I define the different aspects in my data?
So it should all start with the problem you're trying to go solve. That's it. Again, this is, I know we're having a technical audience, but this is something I even push for all the technical audience. If you are trying to go just play around with technology, then yeah, we can have that discussion and say like why this technology is better. But if you're thinking, if we're having the conversation about I want to apply this technology for in the enterprise and what, like, then the question is, what is the problem you're trying to go solve? Because if your problem that you're trying to go solve is I just need to go answer all these questions, then just put it in a freaking relational database, create an OLAP, fact and dimensions. There, you're done. You don't need that stuff, right? And I think the question is when. So I'll rephrase it like, what are the situations where things get more complicated when you start saying, oh wait, I maybe start to rethinking about all of this. So one, if you first scenario is I think we live in a normal paradigm, what I call the application centric world, where we build systems to satisfy a particular application in a use case. And that means that we build a silo for this stuff. And it works perfectly fine. And you can use whatever system that you want to go do. And I build and I solve that application. Then I have another problem, I build another application. Boom. So at the center of the world is the application. Now, but what happens is that that's how we start building these silos. And then people start realizing, oh, wait, I have these other questions. And what do I need to do? I need actually data that's from this application and that application. And what do they end up doing? Building another application, and they start building these things. So you have all these silos of things. At some point, you'll say, this doesn't scale anymore. This is wasting my time. But some other people are like, this is just how we work, and it's fine. We're going to live in these silos. And that's, I think, how all organizations have done that. But then you start entering the problem. I don't even know what data I have, or I get multiple answers depending on how I answer these things. So if those issues if you're starting to have those issues in your organization, that I have a new thing I need to go build and it takes a lot of time. And I'm like, why does it take so much time if what I'm asking for already exists with that other stuff over there? Why are you telling me I have to go wait so much time? Or I'm trying to go find data around these things and there's too much of this stuff. I ask a question and I get so many different perspectives. If you're starting to hit those types of problems and it's actually costing you are losing money because of that. Then I'm like, okay, so you start realizing that you have an issue of what we're going to call metadata management. You have this knowledge about what your stuff means and how it's organized. It's all spread across, and that's starting to generate pain for you. So I think the next step that you should start considering is going into all this metadata management. And it comes into like the worlds of data catalogs and stuff that I want to say, hey, let's actually figure out let's organize the mess that we have. Let's figure out what we have and then figure out how we start organizing. And I think at that point, you can still have more, you start increasing more the maturity on how much you want to go do. So all this to go say is that if now thinking about this from a tech perspective, I always say that your first knowledge graph should be of your metadata. So it should be, you're starting to pull in and integrate the metadata of systems. So I know we just jumped into knowledge graph and we haven't even defined what a knowledge graph is. I'm going to just keep it my very simple, my honest, no BS answer here. Let's actually break it down to what the word knowledge and graph is. By knowledge, the meaning of things. And this is the data model, the ontology, the schema. That is, we're making that explicit. So it's just drawing out the concepts or representing the concepts about a particular domain. If my domain is e-commerce, I'm talking about customers, orders, order lines, products, right? That's my domain. And then the data is the graph part. And why a graph? Because at the end of the day, you're connecting all these things together. And I actually think that graphs are a very flexible data structure because you can take tabular data, you can translate it to a graph. You can take tree style data, JSON, XML, that stuff, put it into a graph. When you do entity extraction over text, you're pulling out nodes, you're doing relational extraction, you're pulling out. It just becomes like that lowest common denominator to integrate all types of sources to go do. Now, if I say so what happens if I start thinking about, I need to go create a schema and ontology about a particular domain, you're probably going to have a lot of discussions with people. Oh, but I think about it this way, I think about it that way. I'm like, you know what? That's true. Let's not tackle that problem. Let's tackle an easy problem where we're probably not going to have a lot of discussions because we're going to have agree. And this is where metadata comes in. A database. What is the ontology, the semantic layer, the schema database? You have a database that have schemas, tables have columns are part of the tables. These columns have primary keys, foreign keys, blah, blah, blah. That's your model right there, right? I want to bring in a dashboard. This is how it's defined what a dashboard is, a Tableau dashboard and so forth. Then you start relating dashboards to tables. And so you start creating that model that represents all the metadata from sources, and you just start bringing that in. You start creating that knowledge graph of your metadata. And that's what a data catalog is. The data catalog is really an application over your integrated metadata coming from so many different sources. Long story here to go say, how do you start how increasing? I think realizing that you have a problem of a lot of managing a lot of metadata because you don't know what stuff means. And therefore, your first application of a knowledge graph should be metadata management, which is a data catalog.
Yeah. And I am working on a problem right now where it's actually already like with one backend, one front end, and like the different lingos you have, like the consumer facing one, but also the one you're using in your backend, which you then have to unite, which often is a very challenging thing because what you're doing in the backend is often abstracted from the front end engineers, which are using a different lingo, which is more customer facing. Can you maybe go into a practical example how that data catalog would look like for a use case you can share?
Yeah, and this is where I'm going to say that I think a lot of it is it's a social aspect too. We got to go talk to people and go figure this out. So let's start. I think about this. If we go from a top-down perspective, right? Sorry, a bottom-up perspective. I first want to bring in all my technical metadata, just the facts of what we observe that are the facts of life, right? I have these. Let's keep it super simple. Example. I want to understand my relationship between my Tableau, my dashboards, my ETLs, which are going to be things, transformations done in dbt, and I probably have Fivetran or some other ETL cloud term, and I have something like Snowflake. Let's keep it super simple like that. So then I'm going to extract all that metadata from these different places. So that's the first thing. So imagine that, think about it when I started off saying you have all these applications and these silos. The database itself is a silo. dbt transforms themselves are a silo. The work that you're doing in your dashboard is a silo. I want to start connecting that all together. So the stuff that's in my database, like in Snowflake, I have my tables, my columns, right? All that stuff in there, my views and that I have there. In dbt, I start making transformations. I have SQL queries and code that I want to be able to connect. And what am I doing? I'm transforming things inside of that database. So there is this one table over here that got transformed to another table, which I may have changed the name or something. So I'm trying to keep all track of those. By the way, that's the lineage, and that's part of the graph. I think there's a table here. Inside, that table goes next to this transform, has this stuff, generates this other table here. And then in another silo, you realize I have the system that is actually doing a bunch of logic too, and there's a dashboard that uses a particular table, but that table is actually inside of Snowflake. But that table was transformed by some dbt thing that from this table, that other from Snowflake. By the way, and where that table comes from, some Fivetran or whatever EL process that was dumped from some other source over there. You want to go do that. We pull that all together. All catalogs do this, but why I see this as a knowledge graph? One, if you only care about dealing with those 4 or 5 sources of data, then you probably don't need to do a knowledge graph. But if you need to deal with a new source that's coming along that I don't know, new source and stuff like, I think that is where you want to have that flexibility to extend and add more things. Now, everything that I just talked about are just the facts that exist. I just pulled that in. Nobody can deny this. That's what these systems are telling me. That's that technical metadata. Now we're going to go talk to the business metadata. And this is where people say, okay, how should we start thinking about business metadata? Let's start thinking about it as what are the terms? What are the words that we use? Let's start creating a list of words, your business glossaries and all these things. You can then start saying, hey, is this a term? Oh, this is a metric. So I can start saying more things. A metric has a calculation around these things. Oh, this term is related to another term. And that relationship is hierarchical. Oh, I start creating a taxonomy around these things. Oh, this term is a relationship between these things. And the relationship name was placed by, an order was placed by a customer. Oh, so we start then adding more and more information around these things. And you can say, hey, a customer can purchase many orders. Yes, yeah, okay, there's a cardinality that I'm keeping track of that. Oh, an order can only be purchased by one customer, right? That's a different credit. So that's more and more knowledge that I'm adding that I can keep track of that in that business glossary that I wanted. So you can start from a business glossary and can add more and more semantics to these. Now, the question is, how do you come up with these business glossary terms? Of course, everybody wants the magic wand. And I think this is where you're like, with AI, it's definitely helping to either identify what these things are or actually create descriptions and so forth. So now I just have my layer of my business metadata. I have my layer of my technical metadata. What we also need to have is this layer of let's call it relationships, saying, hey, this table called CUST _ PR, whatever, right? Oh, that means customer, or that is data about related to customer. So I start saying, I have a concept called customer. I have a table here called CUST underscore whatever. I want to make a relationship between these. Now the question is, how do you create these relationships? I want these relationships to be automatically created. Of course, AI will help to go do that. But then this is where kind of governance comes in, because you say, hey, I'm adding an edge between these two things that the AI said, and you can say, I want somebody to come in and approve. Is that the correct thing or not? Or what should I say? So then that's how you can start building these things little by little. And this is what happens underneath inside of a graph and starts getting built out.
Yeah, and when company want to start going from the application perspective to the more knowledge graph data catalog perspective, putting the data at the center, how do you see that transition working? Like, you have a jumbled mess of different data sources. Like, where do I even begin?
So first of all, this is the social aspect, right? So this is, okay, what is the most important data that we need that we know that we can reuse? And this is actually the main reason why I tell people why you should start investing in semantics and knowledge. So if you create a data set, the data product, whatever you want to call these things now, that's another big buzzword, data product. The value of that is that it should be reused. And that's why do we create all these silos? Is because I need data to go answer this question. And you realize, wait, I could probably use that data. But then you go look at it and you're like, oh, I got these questions. I don't know who to go talk to. What does that mean? You know what? Let me just go start myself. I'll do it myself. And then I do it myself and I solve my problem. And then somebody comes along and says, I have something very similar. I could use that that person doesn't work here anymore. I don't know. I don't want to touch it. Let me get started again. We build more over and over again because we're not reusing the data that exists, and we don't reuse the data that exists because we don't understand what that data is about. So the purpose to actually start investing in semantics and knowledge is because we want to reuse data, extend data, compose data, or combine them. Okay, so what is the value of me reusing data and doing things? This goes to economies of scale. I want to make sure that 1 + 1 is greater than 2. So if I built this data for one particular use case and it's well described, somebody else comes along who has a completely different use case, which I had no idea about, and they're able to go use that data. Look, I made a unit of work to address problem A, and that unit of work is now able to address problem B, C, D, E. And I only focused on one. So I think that's the economies of scale to go do that. So if you are truly, so this is a mind shift that we need to start having. And I think that mind shift needs to be from a technical perspective, saying hopefully the technical people listening, I want to make sure that this work that I'm doing can be reused over and over again. But I also want, from an executive top perspective, saying, I want to make sure that what we're investing in, we can squeeze so much juice out of that. So this is really creating a culture of people thinking about, I want to go not only solve the problem, but I want to make sure that the work that I'm doing is reusable. And for that, it's a culture of that. It's creating incentives around these things. And then, so again, all of this is just a social aspect. There's no technical things to go do here.
Yeah. I think what I always like, I don't like the term data products either. I think data asset is something I rather like to talk about, because you're like building on something that can be built upon in the future. What are some of the things, especially when it comes to data catalogs and knowledge graphs, that you have seen become possible after they were created that weren't possible before?
Yeah, so I wouldn't say it's not they weren't impossible. It's that the cost of doing it was so low and it was faster. So it's like we enabled serendipity around this. So I think it's not. I'm not arguing that it's impossible, right? Everything's possible. It's just software. We have to go write things, right? You can do anything in an assembly code. You can still do that, right? So things that if we look at, for example, things that, let's talk about metadata examples and stuff using very explicitly things on the graph. So one of the stuff I really love doing is that when you look at metadata as a graph, in addition to common things that you do on a graph is like data lineage, right? I want to see things, and you have impact analysis. Oh, if I change this, what is it going to impact, right? Or this number is not happening, right? Those are features, you can code those in. Everybody has that type of stuff, right? So that's just the bread and butter. But if you start leveraging the graph, things that I like to go do is I want to go find bottlenecks in the graph. Oh, what is like in the graph of the metadata? And what would a bottleneck imply? Yeah, it means that there's a lot of either a lot of things go into it and just a couple things go out to it, or many or small things go into it and a lot of things go out of it, or so that implies that it's a very important node. That's a table, a transformation that's being used a lot that depends a lot of things. And then you can say, hey, who's responsible for that? Where's the documentation? So we need to really, how do I prioritize where I should go focus my work on? Finding your nodes, finding your complexity nodes around these things, right? That's a particular example that we're seeing a lot of people with our organization do. So you could then just start applying a bunch of like, oh, graph analytics around these things, finding communities around these. Oh, this is very common things that people are thinking of. This is similarities, right? These clusters. We got a lot of tables or data around this type of same stuff. What's going on around these things, right? So I think just a bunch of like graph analytics you can go apply to that. So that's one particular example. Now let's shift to a completely different example, tying it next to the metadata. I think the value of the knowledge graph, and specifically, again, knowledge and graph. One, if I look at the graph, it's the flexibility and the extensibility to go do this. And knowledge is I can start extending my schema, extending my ontology without having to be dependent of a vendor, which I think this is the value of this. So we talked about Snowflake and eDBT and an ETL, an EL tool, moving, all that stuff. But let's say I want to start bringing in all my employees because I want to also add into my graph the structure of my employees and what teams they're on, because I don't know who should be responsible for this particular table, but I do know at least what department should be. So if something does happen, I want to know who should I go talk to. So bringing people around these things that we're starting to see is people, I want to extend this. I want to bring in we're bringing in our machine learning models. Okay, but this machine learning model, right, takes as input this data over here, has these features, it's being used for these applications. So you start I'm adding it more and more. We're starting to see people integrate and adding like business processes, saying, okay, I want to understand how we do pricing for our product. Okay, so do pricing for our product. We need this data. Then we have this decision model. And the decision model is if this, then did blah, blah, blah. Okay, there's a decision that happens. And part of that decision is you have to go talk to Bob and this person, or Alice over here. Okay, so if you think about it as a graph, this data comes into the decision. People go into this decision. The output is a decision that may go to another decision, and all of that stuff happens. So when we talk about data lineage, how about talking about business lineage? I want to understand how this business works and how we define pricing around that stuff. And if we're going to do a pricing change, I want to understand what are all the pieces that are be part of it and what are the bottlenecks. Oh, Bob is involved in so many different projects around this. So we start combining more and more of these things. I can give a couple more examples, but I don't know. Let's stop there and throw it back to you. Does that make sense? Is that interesting?
Yeah, I love that stuff. I think like the practical hands-on examples, I think like knowledge graphs is talked about a lot, but most examples just take an LLM to extract entities and relations, throw it into some form of storage, and then query over it.
Text, right? So let me talk about this for a second. So what people are hearing knowledge graphs more today is because they're hearing it in the context of GraphRag, and they're hearing it in the context of I want to be able to extract more context out of my documents. Right? Because the current way you're extracting the context from your documents, that you're just doing embeddings and sticking in a vector database, and you're lacking the relationships and the main concepts and stuff. So you want to do that. So that's the first step. And I think it's already shown that's already better. A lot of our work early on is pushed for that. But you're using that for a particular application. And everything I'm talking about here is like really step out and start thinking about the context of your organization. Think about you want to build the brain of your organization, how things work. And that doesn't happen overnight, right? You have to start with the use cases, start with the particularly, and start building that stuff out. Because guess what? That brain, that context can be used for something like GraphReg, can be used for other types of decisions that you want to go do for the other applications, not just for GraphReg. So if goes back to really, why are we doing this? What is the problem you're trying to go solve? And I think you realize that problem independently are really hard, but if I start integrating data and I start treating knowledge as that first-class citizen, helps me go solve all those problems. So maybe what I should be doing is investing in that strong foundation first. And that strong foundation starts with metadata. That I'll tell you is something I learned the hard way. I started doing things all over the place and I realized, oh shoot, I should start a little bit bottoms up with the metadata and then start layering semantics a little by use cases. I ended up boiling the ocean and stuff like that early on in my career.
metadata starts to bite you once things go wrong, and then you actually realize you need it. I think like people realize like graph rag, you need to have a good context engineering for LLMs. What's missing is a little bit like you need a good context engineering for your entire organization as well. That
Bingo.
you actually understand what is the data, where is it coming from, how do I actually use it, what could I want it for.
And but note that not everybody needs to do that investment. If you're a small startup now, just go hit the ground running, go do things. I think that's the level of maturity when you start realizing that it's biting you back because you're trying to solve these big business situations, not even just answering a simple question, right? There's these big problems like we need to improve our operational efficiency of how we are stacking boxes inside of the crates that we're shipping of our products because it's just we have problems all over the time, right? And that's when you realize supply chain itself. Actually, if you look at one of my co-authors is Oral Asilla. He's the one of the original authors of the semantic web vision paper from 2001. He's actually a guy who designed the first version of RDF back in '98. And he's at Amazon, and he's a principal graph technologist at Amazon Neptune. So he gave the keynote at the Semantic Web Conference last year, and he was able to publicly talk about how Amazon supply chain is all now modeled in a knowledge graph and RDF that they've done, runs on Neptune, and it's about all these things. I couldn't get into the details, but it was built for this particular use case, and then all these other use cases were able to start reusing it. That's the economies of scale.
Yeah, and also there's a certain degree of dynamism. Yeah, I hope I used that correctly. You have to consider because in a startup, especially your main data set is probably still in constant flux. It's changing all the time. So tracking metadata around it and how it relates to the things, it's not as useful.
There's no ROI on that. Okay, I tracked it. What am I going to do? I'm going to change it anyway. So we're like, yeah. So this is where you have to be very, again, honest, no BS. You want to go do this. And I think this is mainly more for when you start getting into the issues of scalable enterprises. That's what we're seeing.
Yeah, and it's similar for me. Like feature stores, for example, are in a very related domain, like data lineage, cataloging the different data. How do you actually see like your data catalog and knowledge graph relate to feature stores, and how do they either work together, or does one of the other make the other obsolete?
That is a fantastic question, which I am not prepared to answer because, and I'm telling you, actually, I attended the MLOps conference, which was here in Austin last year. And I was just wandering, listening to talks, and I'm like, there is a whole different world, which I'm not in that world, in that bubble. And they say different words, talk about semantic, but they're very related to what I'm seeing in the data and the metadata world. And they're not talking. Because at the end of the day, it's like the data world does all their work and the data lands in the lake or wherever. And then the ML AI world, specifically ML, right? It comes in and they take that and they go do all these stuff. But then they're like, we're building features. Wait, that's how you're transforming data, right? You have some observabilities, right? In ops, we have all that term over here too, right? You have systems that are tracking where all this stuff is. Oh, that's our catalog and metadata. You have guardrails that you're doing. That's also governance over here, right? Though it's a lot of parallels. Now, I'm not implying that there should just be one tool for everything. Right? Maybe there could be. I don't know. But they're just parallels. And I'm like, hey, let's go hang out at the same bar. Let's go talk and let's learn from each other.
I think that's the issue of AI. I think AI as a field likes to reinvent a lot of stuff which has already been invented a while ago by different fields and ends up with a similar solution in the end.
This is not just AI. It's so many different fields. And so we stick specifically with AI. Back in the 80s, when the focus of a lot of the AI was on symbolic reasoning stuff, you had the AI world doing things and you had the database world doing these things too. Then same thing happens, right? They use different words, right? And it's just common human nature because we live in our own bubble and we think about things. And at the end of the day, it's validating. It validates, hey, we're talking about it, right? I think this is why at least I personally consider myself somebody who likes to build bridges. So I like to hop around and observe things because then maybe you observe and nobody pays attention. Okay. But maybe you do find these things saying, hey, 1 + 1 is greater than 2 on this stuff. So let's work together.
Yeah. And what are the types of questions or the questions you actually as to figure out the data catalog and the knowledge graph you have to construct for a certain use case or for a certain business? Like, how do you actually run through it? What types of data do I have? What types of use cases do I have to support?
This is a great question. So I think if we look at it from the data governance in this space, what we're seeing in the market right now is from a use cases, there ends up being, I think I'm going to bucket like three use cases. One is around search and discovery. I don't know what data I have. I need to search for data. And the reason I want to search for data is because we're trying to be data driven and do things with data. But so what is the actual use case? I push people more. Yeah, I get it. This is a problem everybody has. They can't find it. But what are you trying to go do with their data? You really want to get to more details. But in general, they want to go, they're trying to find data so they can answer questions to go solve a problem that's going to make them more money and save them money. And something like that. That's one part. And that's where it's search, discovery, these data marketplaces fall in. These data products are falling into all these, into that area right there. By the way, I agree with you. Like we're recording this right now, but this weekend was Data Day Texas here in Austin. And yesterday we had an entire session for an hour, like 20 people talking about, so what is a data product and everything. And at the end, it was, I think Joe Reese was in the room. He's, look, if I were, you think the plumbers are in their conference saying, hey, what is a wrench? And no, people would think about us being like, we're insane talking about this stuff. So I agree that this being so pedantic is not helping us. And I think it's a very technical computer thing that we want to be able to have things so defined. I'm like, okay, so we define it. So what are we going to go do? How's that going to change our lives? Like, anyways. Okay, so that's one thing on the search and discovery. The other application is around governance. So it is about, and I like to see governance in two aspects, which is, think about it as the protective one or kind of the enablement one. So the analogy is, why do we have brakes in a car? So usually people say, so we can slow down. I'm like, yeah, be protective. I want to make sure, they don't have accidents. But you can also, in the way of interpreting brakes in a car, is that I want to be able to drive very fast safely. So then the governance is, okay, who has access to the data? Where is our PII? Who's responsible for this? And all that. That's the governance aspect of things. And the third one, I call it more in the technical, the data engineering side. And this is, I want to have my lineage. Where's my data coming from? Is the contracts, the quality, all these types of aspects right there. So I think those are the three main buckets around that. So those are the three main use cases. And now I forgot your original premise of the question. Okay, but now that I've described those three main use cases, ask the question again.
I was asking, I nearly forgot the question as well. No, I was going in the direction, like, how do you see it? What questions are you asking when you start building the knowledge graph and figuring out the data catalog that you want to build?
So the first question is, which are the use cases that you care about? Are you more during the search and discovery data marketplace data products? Do you care more about the governance around new things? Do you care more about the data engineering types of stuff? So that's the first thing they're going to go do. And then after that, we want to ask people, so how do you measure success? What is your goal? How do you know that you are being successful? So is it adoption? Is it usage? So if I'm doing search and discovery, my goal is I want to have more people finding data, and I want them to be able to find more of that. And by the way, that can also apply for governance, because and by the way, these are not isolated, right? People are not like, I'm going to only do one. No, you end up doing all of them, but which one is the one that's driving you? So the search and discovery will be, I want more people to go drive and find data and stuff like that. The governance can be a very regulatory thing. We just got fined for something. Our goal is that they get fined again. Okay, perfect. I tell people, if that's your real goal, it's like, you got to be cautious about that, because then if you really never want to get fined, just make sure nobody touches the data, then you're done, right? But then, so I think if people come in from a very kind of regulatory point of view, I really tie that to, but you also want people to go use the data. So let's make sure that you're making sure that you're keeping the data safe, but making an enablement of that. So therefore, there should also be an adoption, a safe adoption, that nothing bad happens. If you're coming from a data engineering perspective, you may be saying, yeah, we get so many tickets around this stuff, and people are complaining around that stuff. So then you also then your goal is to see that those requests come down, or the time it takes to resolve them are faster. But then at the same time, you want to make sure that the usage goes up. So I think an overarching kind of theme that we realize is that people should say, I want the adoption of data. I want more people using data to do these types of things. So that's we want to set the stage with folks like that. And then I think this is when it's really valuable to bring the product mindset, the product management, and then not to get the data products. It's just in general. Who are your consumers? Who's going to be using this? What are the problems that they're going to try to solve? Finding data is not the problem they're trying to go solve. They're trying to reduce churn. So they need to have a lot of churn customer data. Okay, so then let's figure out what are the customer data on these things to go do. And then, our concern is that people complain about there's so many, the numbers don't match around all these things. Okay, so on what topics? So then that's how you start realizing what are the things that they need to start investing in? What are other types of sources that we need to be able to go in? Which ones should we be focusing on? Which one should we not be focusing on? And then the honest thing is that for a lot of these use cases, you're just using the kind of the very foundational bread and butter stuff of a catalog where you don't even need to go into the advanced kind of capabilities of a knowledge graph. What we do see later on is that everything I just described is like the foundations. Like you need to eat your vegetables and go to the gym a little bit, right? And do that type of stuff. And when they start doing that, they're like, okay, we came here with that problem. We got that under control now. What do we do next? And obviously AI is one of the drivers of what to go do next. People want to go do AI. And that's when we're saying, okay, you want to go do AI, you need to have your context. Then you need to start investing more in your metadata and semantics to go do that. And then that's even the work that we were doing early on was like, I want to be able to go chat with my data. Things that we're doing now is I want to go chat with my metadata to ask questions and build these apps. So that's when we're seeing the maturity heading towards it. If I kind of summarize this right now, is there's like the true foundations that comes in on those three aspects. So search and discovery, governance, and kind of data engineering, data ops. And then from there, the next step people are coming into is that they want to have that, start adding AI to things. And the first level is conversations with your metadata, with the context, with, hey, what does this mean? How do we define this? Actually saying, I'm trying to go solve this problem. What should I use to go solve this problem? Oh, you should be thinking about this. You should be thinking about this data. By the way, you should probably talk to this person or these teams. And then I think after that, they're doing much more. Then they get into more advanced AI. Oh, I'm building AI agents and stuff. And I want my agent to orchestrate to the context because I want to chat with my data and combine structured data with unstructured data. By the way, combining structured data with unstructured data, knowledge graphs are playing a big role in there. So they realize if I want to go do that, I probably need to go start my foundation. And all the work that you're doing early on to do the basics, I need to find my data, you're building that foundation of that semantics. You're building that knowledge graph little by little, which at that moment, the original moment, you're probably not taking advantage of it, but you're still building that stuff such that when you're ready to go do it, take advantage of doing more advanced AI stuff, it's there for you.
Yeah. And when you have the use case, for example, you want to reduce churn or you have data faults you want to fix, how do you determine, okay, what's the minimum amount of coverage across my data that helps me fix that?
So this goes into the whole methodologies and processes around this. Again, talk to people. This is a big thing around it. And I have the approach I propose always, I call it just the iron thread. And an analogy to this also, a parallel, I think one of the technologists I admire and read a lot is a guy, Gregor Hope. He was at AWS recently. And big guy. He has a book called The Architect Elevator for enterprise architecture. And his analogy is that these enterprise architects, the best ones can run the elevator down to the engine room, but all the way up to the penthouse. Right? So you're navigating that. So an iron thread approach is you say, look, let's take one particular question, a very small set of questions around things that you can tie directly all the way up. Who's asking this? Why are they asking it? What is the problem it's causing? How are they solving this problem today? Why is it painful? What happens if they don't solve this problem? Get all that. And then you start driving all of that all the way to the bottom and figure out what you need. You go figure out the politics of the people that you need to go deal with to go do this. Oh, what does customer mean around this stuff? Yeah, there's 2, 3, 4 people of these. Let's go figure out what that is. Where is this in the data? Where was the code written for that stuff? And then you just got to go all the way down until you hit the rock bottom. You say, okay, this is the ultimate source. You created that thread around that stuff. And now you're able to solve that particular set of questions. And then what you realize is that once I've done that entire thread, what other questions or problems can I be solving with the work that I did on that? And what you realize is, oh, I can probably solve a couple of other things that I was not even thinking about. That's a serendipity, right? That's the 1 + 1 is greater than 2. And now you have a process. And then from a social perspective, you started to meet people. You started to gain trust with other people. You now technically know what's working, what's missing. You're already realizing, hey, that would be a good candidate for stuff. And then you do it again. It's a thread, right? So then add another thread to go do that stuff. Add another thread. And then you figure out that muscle, how to go do that. Then you have other people can say, hey, here's how you should go do this, and let other people start building those threads, and then you start getting that stuff together. So that's the approach that I suggest to people to go do.
And we walk down the ladder or the elevator. We're at the bottoms. And you start constructing the knowledge graphs. How do you do it? What do you use for the extraction? Or is the first knowledge graph mostly human-made?
So in this conversation that we're having up to now, which I didn't even know where we were going to head towards, so I love this, how we got. We've been having all this conversation about data catalogs and metadata, right? So from that perspective in the enterprise, that's built automatically because you're just pulling in the stuff, the facts. You're creating collectors or drivers or tools like what we do. We do that for you, and then we already have your ontology that represents what tables and columns and dashboards are and how they relate that. So that first technical metadata is built completely automatically for you. Now, the business terminology one, that's where sometimes the first level of things are going to happen manually. So what we typically see is that either people already have some sort of a business glossary somewhere, some spreadsheets that people have, it's in a Confluence doc, whatever. So then they can easily have it into a spreadsheet and then that into some CSV file, whatever, and then we turn it up and then we load it. And now, so it's manual because somebody had already existed, it was created, but then turning that word that thing into the graph, that done automatically, right? You just can transform that. Then comes making those relationships. Those relationships can be done automatically, but then I think this is where the human comes in the loop, right? You want to make sure, did that relationship make sense or not? Or what we see a lot is people making those relationships manually. But that knowledge graph right there is a metadata knowledge graph, right? It's talking about this concept customer. It's related to this table, and these tables are these set of tables. These tables are in these databases, and there are these dashboards that use that stuff. So I think that's that metadata knowledge graph. Now, if we take another particular use case, let's talk about the stuff that's happening in GraphRag, and people are basically extracting things from text. That's usually almost always done automatically, right? Because you're just basically doing NLP, right? You're doing entity extraction, relationship extraction, and you go build these things. But what I see a lot is that knowledge graph is really more focused on it's more graph and less knowledge. Because you're pulling in here's this thing, Bob and Alice and so forth, right? You're extracting them. Okay, then somehow it's person, but maybe you define one person, then they define this one as a customer, but then you start having all these different. The knowledge part is not really well aligned because you did everything automatically. You didn't add any governance around that. Nobody's going in and managing what this stuff means. Or how do I know that it generated two entities for Bob, but was it the same Bob? Or they're different Bobs, right? So that's the process that happens when it's fully automated. When it comes to text, you have to do this fully automated. But I think there lacks right now a notion of how do I do some sort of governance or just understanding, did that extract it correctly or not? And I think that's something that we're in new territory, which is like how to understand that semantics, that governance layer on top of the knowledge graph that is extracted automatically from text. So that part is fully automated, but there may have mistakes. But I think right now, the situation that we're in, we're not doing much of the manual stuff. I think we need to go do that. Then we look at stuff like, I want to go build my knowledge graph of my data that's inside a relational database. So in that first scenario, I'm talking about the metadata. So I'm like extracting the table names, the column names, all that stuff. And in this third one, I'm literally talking about what's inside the data. I want to create a knowledge graph that says Bob made this purchase on this date on these products, and we have all these products that are related and so forth. That is, you can see my back. I have a book right here. That's the book I have, which is about designing and building enterprise knowledge graphs from relational databases. What I see, I call this an era before LLMs and after LLMs. Before LLMs, it's always been very manual because you want to understand what this stuff means. So you're like, hey, what is a customer? Okay, I can create a node called customer, and there's a table called customer. Okay, but does that mean that every single row in the table customer actually means what is a customer? Maybe the customers are the ones that are only active. So I have to know it's only where active is 1 or A or whatever, right? How do you start finding all these things out? And I think now with LLMs, it's a way of helping us create these mappings, these transforms. We're able to go do that, be able to semi-automate that. But I think for that, you actually always need some human oversight and governance if you're using this for an enterprise perspective. where they're going to require that governance aspect?
I think that's two very different areas. The one, knowledge graph, is very curated and probably way smaller. And with LLMs, we see these really open knowledge graphs, which are like infinitely expanding. I'm really torn on the second part, whether it actually provides any value and whether I actually want it, or whether I want to constrain the entities, the relationships I actually extract to the specific use case I'm handling.
I agree with you, but we need humanity basically to figure this out on their own. We need people to go off and try things and let them smash into the wall and see what works and what doesn't work. Because I'm with you, but maybe people doing this, they find things that we can go make very useful. My hypothesis is that depending on the use case, and my bias towards more enterprise use cases where you need to have accuracy, you need to have explainability, you need to have governance around this stuff, you need to generate trust around this. You need to start investing what I call in that semantics to constrain these things and having oversight around that stuff. But other use cases you may not need to. But I think there's other situations to even consider. For example, let's look at Wikipedia. Wikipedia scales. There's humans involved. There's incentives for them to go do that. Why are Wikipedians incentivized to go do that? I actually don't know. And I'm very curious to go do that. So it's like, how do we get that? Because the argument for not doing things such in a constrained way is because it won't scale. I'm like, yeah, that's true. How do we go scale? I think LLMs are helping us go scale. A lot of the research that we're working on right now is how to extract what's in people's heads to scale with LLMs. And then I think we're starting to go see that. But like we've been building Wikipedia for a long time and Wikidata, all that stuff. How is that working? I find that interesting. I want to learn more about that.
Yeah,
people have done a lot of research around that stuff. I just need to find time to read the papers. People have been working on this already.
I'm really torn on it because I think LLMs are also really fussy. They've probably been trained on 100 definitions of a customer. And which one are you using in that case? I'm not sure.
And I think this is why, if you think of an architecture around this, is you have, I think LLMs will touch everything. AI, and it's not just LLMs. There's like normal machine learning models. So you have AI touching everything. On top, think about it as having the problems that you're solving, which you create applications, you create AI agents and so forth. And then at the bottom, you have the data, which you're going to use to go answer those questions. That could be structured data, tables, columns, right? The text, all that stuff. How do you get from the applications to the data, right? I think that we've been working on this where we create your data warehouse and stuff like that. But what we really want to be able to do is, I call this, you want to build that enterprise brain, that context. And the analogy here is, think about it as the library. I'm organizing my library. And when you have your library, you have a question, you go to the library. Once upon a time, people would go to libraries, believe it or not, right? So if you go to a library and you know what you're looking for, you can just walk in. You can find the signs. Go to this. There was self-service to go help you find the book. You find the next book. This is what I need. I check out. I leave. I'm done. But sometimes I'm trying to solve a problem which I don't know, or I tried it, I couldn't find out. So you would go to the reference desk, to the librarian, and you say, hey, I'm trying to solve this problem. I need this. And the librarian asks you questions and tries to understand really what is your information need, what you're trying to do. And, oh, hold on. Okay, you maybe need this, and you need this, and you need that, right? And then you go do that. And by the way, I can't answer your question right this, but this may give you more things for you to go think about and reevaluate what you were really trying to go do. So what is the analogy of that? So I think that library is that enterprise context, that brain, and I'm calling it your governed data and knowledge. And then we need to have that reference desk, that librarian, which you don't always have to go to the librarian. But that librarian, think about it, is your orchestration. I'm here. You need questions? I can tell you, go here. Oh, you want to know what a customer is? Boom. Here are 5 definitions of customers. You want to know how many customers we have? Bro, here are 5 different answers based on these 5 different definitions. And if you have more questions, you can talk to these people. That's what that reference is. So I think that's the kind of the evolution of things that we're doing, that we're heading towards.
What I'm really curious about, in your mind, what makes something a good entity and a good relationship that should be included in the knowledge graphs, and what is just a property?
Oh, okay. So a rule of thumb that I have, and by the way, this is an art and a science. A lot we talk about these things, right? So it really depends on what you're optimizing for. If you're optimizing for a particular query performance of something, then maybe you merge everything and everything is a property. So it really depends on what you're merging, what you're optimizing for. So that's the first thing. My answer to your question is it depends, which I always hate that answer, but this really is okay. But if you put optimizations or query optimizations aside, a rule of thumb I say is if I need to say more things about something, then that something should be an entity. And that means, and that implies that it has a unique way of identifying it. Because I need to point to it. I need to say that thing. And that thing is 123 or ABC or FUBAR, whatever. It has a unique entity. Go do that. And then what sometimes happens is you say, oh, you don't realize that you're categorizing things, and then it starts getting bigger and bigger, and then other people want to go point to that thing and they don't have a way to point to it, and then that's when you realize I probably should need to normalize it and extract it out. So an example, a person has an address. Okay, I could just create a concept called a person, attribute, property name, email, street address, street, city, but there, that's fine. But what if I want to reuse that address again somewhere else? I want to say that's a home address or it's a work address. I'm starting to say things about that address. Okay, then let me extract that part and make it an address. And I say a person has a work address and so forth. And I can point to that. I can reuse that address for more things. And so that's the rule of thumb. But I also say that don't be pedantic around these things. Just start small, iterate around this. And the other thing is, you're not probably modeling a domain that has never been done before. So look at what has been done, and that's why you have reference models, and go inspire yourself from that. And I think the one I'll recommend everybody to look at is go to schema.org. Schema.org is the ontology, the schema that all the big web giants, Google, Yahoo, Microsoft, got together almost 15 years ago to start building small and got bigger and bigger. And it takes time. It's done in completely decentralized ways. Use that, for example, as a reference, as an inspiration. In finance, the favorite one is FIBO, the Finance Industry Business Ontology. Every domain will have a bunch of stuff.
Yeah. I think at the moment when I'm looking at the different knowledge graphs tools, especially when it comes to storage and querying, I don't see many people actually using a lot of graph analytics. I think a lot of it is really over-engineered for 90% of use cases. I would to know, what do you actually recommend for storage when people build their knowledge graphs?
So I'll say that for some context is I think the knowledge graph database market stuff has always been slow because people have not been paying attention to it. And I'm hoping now that there's going to be more and more interest to it. So that's why that is my reasoning of why we don't have enough tools or better tools to go do things. And honestly, there's not that many, right? If you think about it from a database perspective of graphs, right? Neo4j is obviously the big popular one you go do. Then you have the cloud one. So AWS has Neptune. Google launched a recent one called Spanner Graph.
Yeah.
Microsoft has always had something called Cosmos DB, but they're building something else out. I know. So there are other ones like in Europe. There's a company called Ontologies that has GraphDB. They merged recently with the Pool Party, which is a company that does taxonomies. There's another one called Stardog. They're all really small. I think there's a lot of open source ones now. Kuzo DB, I think, is one from an academic buddy of mine. The folks at DuckDB have put in a graph layer of these things. There's also Tiger Graph. So there's all these things coming out there. Then some of them are very property graph and Cypher. Some of them are also RDF and Sparkle. Some of them will do both. An open source one to go look at is Apache Jenna. All right, that's an RDF one, and you can have different storage layers. We've been public about this at data.world. We use everything's in RDF, and our storage layer that we have is something called RDF HDT. So header dictionary triples. It's basically like the Parquet formats for RDF. So we've separated storage and compute, and part of our compute engine is Apache Jenna. We've extended it to support this, and that works for us at a web scale. Data.world is, I think, one of the largest, if not the largest, open data community, too, in addition to being an enterprise data catalog. So we have 2 million users. We have 500,000 data sets, open data sets, and every data set people upload, it's a CSV, it's a Parquet. We have it in RDF from these folks, and it's all queryable. So we've been able to show how this scales at a web scale.
Do you see enterprise knowledge graph usage evolving? What are the trends you're actually excited about, and what do you think we should throw away?
The number one that we're seeing is metadata. So if you look at, I don't know, I'm going to bet that your audience doesn't pay attention or probably even hates the analysts like Gartner and stuff, but hey, they do have a pulse on the market. And it's very clear that metadata, how they even present the market is that metadata and all this stuff is all knowledge graphs are a foundation of it. That's what I'm really excited. People are realizing that metadata is a graph. I think what a lot of the analysts said, hey, metadata is a graph. I'm just connecting things, right? And then you want to bring in more things and connect more and more things to that stuff, right? So I think realizing that knowledge graph, your first knowledge graph application is a metadata application. That is a trend that I'm now seeing more and more again. So that's number one. Of course, with AI, LLMs is now starting to think more about ontologies and taxonomies to go add extra context. Ontologies was always a very, don't say the O word, we would say, but now people are starting to go say these things. And people think they're cool because they're saying this new cool thing. I'm like, I've been working on this stuff for 20 years. And people have been working on this stuff for 50, 60, 70 years, even more. So I think that's the next trend is knowledge graph as being the source of the context that these LLMs lack. And those two things they're just one and the same. The metadata knowledge graph of your enterprise you start building that out, is the context that can be used for everything in your enterprise, including all the AI LLM applications that you're building. So that's the number one trend.
Yeah. What is actually something that you would love to see built in the space that you aren't building yourself?
I hate that I don't have an immediate answer to you. It makes me feel bad. It makes me realize I'm in my own bubble. And because I'm working on the stuff that I think it really needs to be done. But let's see. I think I would love for things to be I don't know what would be built to accomplish this, but one of the things that people say, I can do this why a graph? I can put everything in a table and do this, right? So there's that mindset of, I know I have a hammer and everything for me is a nail. So everything's a relational database. I don't need that. So I would like things to be much more easier to say, it doesn't matter. It's all that database. It could be relational. It could be tabular, almost like these multi-model databases that have existed. But I think it needs to be, have a way to bridge that gap of why do I need to go do the graph? It's already there for you. I want that to be. It's already there to go to merge it. So I think there's something there for databases to be done. Imagine you have a way where I can query this in SQL, I can query this in Spark, I can query this in Cypher, and it's all the same data, whatever application you want to go do. And which in reality would mean that the semantics is a first-class citizen in how you're storing, modeling, and querying your data. So I think that's something, because right now we just see silos of here's a relational SQL database, here's a graph database that only does Cypher, here's a graph. Like, I think there's an opportunity to merge all this stuff right there.
So someone has to build SGLang on a different level.
I think for starters, for example, like a Neptune or all these other graph databases are like now having the one graph project where it doesn't matter if it's one or the other. I think the ISO standard for SQL is that they have a version now which is called PG or SQL PGQ, which is an extension of SQL that does graphs. And they also have the graph query language. So things are heading in that direction. I just want to go start seeing more of these implementations.
Yeah. What's next for you and data.world? What are you building right now that you can already teaser?
What I've been teasing here is so we've been extracting metadata from all these technical systems. I want to extract metadata from what's in our heads. I want to be able to extract metadata. I want to extract our tacit knowledge. I want to be able to start connecting these things together. So that's one thing. And the other one is really showing more examples and pushing out things of all the really cool things that the graph analytics stuff that you can do over your metadata and how that actually plugs it back inside to your graph. Is, hey, we learn this thing, so then this is something you should go do in action.
So what can we take away when we want to build with knowledge graphs or we want to build knowledge graphs? If you look at them from a high level, knowledge graphs connect data points meaningfully. So they map relationships between concepts and make more hidden connections actually visible. So it's like an organization's brain in the end. It's not just storing the data, but also understanding how things relate, which are often very use case, domain, but even company specific. And data catalogs, on the other hand, track what data you have and what it means. So it's like a library index of data assets in the end, but also all the relationships the different data assets have to each other and the attributes they have, like access controls and things like that. And when you need them, so you first of all, you should always start with a problem. You don't build these systems just because they are trendy. You build them because you have a problem that actually is worth solving with them. So you need a data catalog when people waste time searching for data. Teams get different answers for the same questions, or you're losing money from poor data management. And you need knowledge graphs, on the other hand, when you have to connect data across many sources. The relationships between the data often are very important, so they carry a lot of meaning and a lot of context. And you also need the context for the AI system so it can make better decisions. So when you build your first systems or you want to go into the direction of knowledge graphs, you shouldn't start with knowledge graphs, ontologies, taxonomies from the get-go. You should start with metadata. So you should think about, okay, how can I add metadata to the existing data I already have? So add it on top of your current system, add it as attributes in your vector database, in your Postgres database, and add it as a column and use it to filter. And then over time, you can start to think about building full knowledge graphs. And you can then basically create it very naturally and add business terms, add definitions to the different terms later. I think what was pretty interesting is he talked about the 3 key use cases he's seeing, which is search and discovery. So basically, you have to find relevant data quickly and understand what data means and know who owns what. And I think like this is the main use case we see for knowledge graphs right now, like beyond they're specializing on basically enabling search or building a data catalog on all data assets. So it's like on a higher level. But if you're building a knowledge graph, for example, for search, I think the same applies. You want to find relevant data quickly for the specific search query that's coming in. And the second one is basically governance. So basically you track data access, you monitor sensitive data and ensure compliance. On like a use case specific level, I think you can apply the same. Basically, we talked last week with Danielle Davis on temporal RAG and adding a time component to your data. And I think like this is the governance component you can use a knowledge graph in general for as well. Like when was the data created, when was it updated, and when might it be outdated? And same goes for monitoring sensitive data. So you can add the relationships and rules to the knowledge graph that only certain users can access it. And then you basically have like the technical operations part, which is, I think, doesn't really track to like the regular knowledge graphs we would use in search, which are more about like data lineage, track data quality, and manage dependencies. I think this is not as mappable onto different use cases, but the one data.world is working on. So to summarize it again, to make it work, build incrementally. So pick one problem, map the path. So like, how can you go from a business need to a technical solution, then create a single thread end to end and expand carefully from there. So it isn't about size, it's about solving the problem you have at hand. So start small and make it useful fast. So don't over-engineer, start simple, focus on actual problems, balance automation with human oversight, and remember, if you're a small startup or like if you're very early in your AI journey, you probably don't need a knowledge graph. Yes, that's it. We will have one more episode on knowledge graphs next week, and then we have, I think, 1 or 2 more search episodes before we actually move on to the next season. So Let me know what you think of the episode, and otherwise I will catch you next week.
And so start adding more tasks and stuff into your graph and connecting it to people. So those are the two aspects that our lab is working on right now. Can you?
Yeah, if people want to learn more about knowledge graphs, data.world, data catalogs, or you, where would you point them?
You can find me on LinkedIn. So just Juan Sequeda, that's one. If you want to learn about data.world, just go to data.world. If you want to learn more about knowledge graphs, I have a book called Designing and Building Enterprise Knowledge Graphs. Actually, just ping me, just find me, and I'll just send you a copy. I just want people to go read this stuff. My colleague who I work in our lab, Dean Alamang, has a book called Semantic Web for the Working Ontologist. So if you're interested in learning about how ontologies work and built, that's the textbook for that. And then, sorry for being more shameless plug on our podcast. You can listen to Catalog and Cocktails, the honest, no BS data podcast. Thank you.
So what can we take away when we want to build with knowledge graphs, or we want to build knowledge graphs? If you look at them from a high level, knowledge graphs connect data points meaningfully. So they map relationships between concepts and make more hidden connections actually visible. So it's like an organization's brain in the end. It's not just storing the data, but also understanding how things relate, which are often very use case, domain, but even company specific. And data catalogs, on the other hand, track what data you have and what it means. So it's like a library index of data assets in the end, but also all the relationships the different data assets have to each other and the attributes they have, like access controls and things like that. And when you need them, so you first of all, you should always start with a problem. You don't build these systems just because they are trendy. You build them because you have a problem that actually is worth solving with them. So you need a data catalog when people waste time searching for data. Teams get different answers for the same questions, or you're losing money from poor data management. And you need knowledge graphs, on the other hand, when you have to connect data across many sources. The relationships between the data often are very important, so they carry a lot of meaning and a lot of context. And you also need the context for the AI system so it can make better decisions. So when you build your first systems, or you want to go into the direction of knowledge graphs, you shouldn't start with knowledge graphs, ontologies, taxonomies from the get-go. You should start with metadata. So you should think about, okay, how can I add metadata to the existing data I already have? So add it on top of your current system, add it as attributes in your vector database, in your Postgres database, and add it as a column and use it to filter. And then over time, you can start to think about building full knowledge graphs. And you can then basically create it very naturally and add business terms, add definitions to the different terms later. I think what was pretty interesting is he talked about the 3 key use cases he's seeing, which is search and discovery. So basically, you have to find relevant data quickly and understand what data means and know who owns what. And I think like this is the main use case we see for knowledge graphs right now, like beyond they're specializing on basically enabling search or building a data catalog on all data assets. So it's like on a higher level. But if you're building a knowledge graph, for example, for search, I think the same applies. You want to find relevant data quickly for the specific search query that's coming in. And the second one is basically governance. So basically you track data access, you monitor sensitive data and ensure compliance. On like a use case specific level, I think you can apply the same. Basically, we talked last week with Danielle Davis on temporal rack and adding a time component to your data. And I think like this is the governance component you can use a knowledge graph in general for as well. Like when was the data created, when was it updated, and when might it be outdated? And same goes for monitoring sensitive data. So you can add the relationships and rules to the knowledge graph that only certain users can access it. And then you basically have like the technical operations part, which is, I think, doesn't really track to like the regular knowledge graphs we would use in search, which are more about like data lineage, track data quality, and manage dependencies. I think this is not as mappable onto different use cases, but the one data.world is working on. So to summarize it again, to make it work, build incrementally. So pick one problem, map the path. So like, how can you go from a business need to a technical solution, then create a single thread end to end and expand carefully from there. So it isn't about size, it's about solving the problem you have at hand. So start small and make it useful fast. So don't over-engineer, start simple, focus on actual problems, balance automation with human oversight, and remember, it's if you're a small startup or like if you're very early in your AI journey, you probably don't need a knowledge graph. Yes, that's it. We will have one more episode on knowledge graphs next week, and then we have, I think, 1 or 2 more search episodes before we actually move on to the next season. So let me know what you think of the episode, and otherwise I will catch you next week.